My name's Wendy Flavell. I'm Professor Emerita in the Department of Physics and Astronomy at the University of Manchester. And I have had a career in surface science, beginning first in chemistry and transiting to physics partway through.
So tell me, how did you first get into surface science?
Well, I did an undergraduate degree in chemistry, which was in two parts, called, unsurprisingly, Part 1 and Part 2. But Part 2 was a complete year of research, which was a great introduction. I'd been doing some lectures in photoemission and I'd got very interested in that topic. And so I asked the lecturer concerned if I could do the Part 2 there. And then, of course, I was hooked. Of course, this was a long time ago. There were, of course, no women in the lab at the time. And I did find that I had to learn a lot of skills, which I wish I'd been taught at school, like metalwork and woodwork. Had to learn to use a spot welder, and I didn't know how you do a flange up, and that involves two spanners, and I didn't know what a torque wrench was and all those kinds of things. But I suspect actually that everybody came to the lab with some deficiencies in their knowledge, but I didn't realise. But I was completely hooked after 1 year, and I carried on to do a PhD DPhil in the same lab.
So do you have any exciting highlights from your research?
Well, I think I'm particularly proud of the work that we've done on developing next generation solar cells, because most of the new materials that you would use are unstable in some way, subject to degradation. And of course, that degradation goes on at the surfaces. So that surface science is absolutely really crucial. So we've been studying perovskite, solar absorbers, and also colloidal quantum dots. We've been able to really pin down some of the mechanisms of degradation, for example, in water, using NAP-XPS. And we've been able then to understand at an atomic level what's going on, to the extent where we can then devise a passivation strategy. And we've been able to prove that that improves both the lifetime and the efficiency of the devices that we make. So the whole of the work that we've been doing in that field, I feel, has been very fulfilling, because you feel that our surface science is really contributing to the renewable energy agenda.
And would you say that gender representation within the field has changed throughout your career?
It's certainly changed. It's still not as high as it should be. When I was a research fellow, I just looked at the low proportions of women around in various grades, but I just thought it would just work its way through the system in 20 years, because the levels of PhDs would just work through. And that just didn't happen. Yeah. And it took me a long time to realise how pernicious things like unconscious bias are, and what an effect they have. So I think things only change when the people with the levers of power actually genuinely believe that there's an issue that they need to solve. It has changed for the better. So when I started out, I would certainly be the only woman at a surface science conference, or maybe one of two. There were two of us, actually, that always got to share rooms at conferences, and we used to joke about it. And that would be pretty unthinkable now. And when I got a chair in surface physics in 1998, my male colleagues were very excited about this, and they decided to ask the Institute of Physics how many female professors of physics there'd ever been in Manchester, so in the UK before. And the answer came back that there were 5. And my colleagues were, "Oh, isn't this wonderful? She's only the 6th female professor of physics ever." And I was thinking, who the hell are the other 5? Because I didn't even know there were 5. No, I mean, obviously that would be unthinkable now. Yeah. And towards the end of my career, we got to a stage where we were getting towards that magical 30% of representation, when the researchers tell us that's when women's opinions start to be taken seriously. But it did make a huge difference, actually. It was like a breath of fresh air. Yeah. And at the end of my career, I no longer had to behave like a man. And I'd been doing it for so long that I didn't realise I was doing it, but I could have some different conversations with people, and the whole of my working environment felt a lot easier.
Yeah. So it sounds almost like you couldn't bring your whole self until a certain point where you felt that you could behave, you know, like a woman, like yourself.
Yes.
Yeah.
No, that is true. I took a conscious decision early in my career that I was just going to have to behave like I was a man and use the same amounts of aggression in situations, for example. And I always really felt like I was a square peg in a round hole. And I really just forgot I was doing it until there were suddenly more women around. And I thought, and breathe, you know. So yeah, it is better than it was.
Yeah. And so what proportion of your career, roughly, would you say you spent acting like a man or, you know, not being yourself? Was it most of it, or?
Probably about 25 years.
Oh my goodness, that's a long time.
I know, it was only about 10 years ago when there was suddenly enough women around to have a different conversation and for that conversation to be listened to. Yeah.
Would you say that UK academic policy and the changes within that have had a positive impact on surface science and, you know, STEM in general for female scientists?
I think it definitely has. So the Institute of Physics Juno programme, also Athena Swan, and the attention paid to it by research councils, and also the REF, which is the UK National Research Assessment exercise. Speaking as a former REF panellist, early on in the process, it was clear that some places were just paying lip service to it and going through the motions of ticking the EDI boxes. But actually, very gradually, things have changed, because I think that departments that do implement good EDI policies realise that it creates benefits for them. And there are massive benefits from having a diverse and happy workforce. And I mean diverse in every sense of the word, whether protected characteristics or whether intellectually, really in every sense. And as the benefits of having more people from different backgrounds contributing to solving the problems becomes clear, then I think the dial's shifted. So it only happens very slowly, even when people have got their hearts in the right place. So in my own department, for example, it's taken about 10 years to get from 20% female physics undergraduates to 30%, with a huge amount of hard work in between. But you can just sense things moving very slowly. So those things, I think, have been created by those types of initiatives, actually, frankly, by people being forced to do something about it and then actually finding the benefits of that.
And do you see a difference for women earlier in their career between how things were for you and how things are for them? And do you, in a sense, feel that that's gratifying if it's a bit better for them than it was for you?
Yes, I do. I hope it's much better for them. Sometimes I'm asked to do talks on women in science and to go through my own career. And when I go back through my career, I think, my God, did that actually happen? Did that happen? Because certain things are unthinkable now. You know, like there only having ever been 5 professors of physics in the UK. You know, that's just, the landscape's changed. And that's happened on a number of things. So that's really gratifying. Some things don't change. One of them is the Miss Triggs phenomenon, which is, there's a famous cartoon where there's a group of men sitting around and the chair of the meeting says to a woman, "That's a very good idea, Miss Triggs. Now, would one of the men like to suggest it?" And I actually showed this in my talk because it used to happen to me all the time. And disappointingly, it does still happen to younger female researchers now. So there's still a lot of work to do, but I am gratified by how much has changed over the course of my career, yes.
Good. And would you have any advice for some XPS or surface scientists in general who are quite early on in their career?
Well, what strikes me about surface science is that it's really contributing powerfully to some of the global problems that we have at the moment, whether it's clean catalysis or atmospheric chemistry or solar power battery technology. So I think it's a way of contributing to important problems, but also you can come to it from so many different backgrounds. So I came from chemistry, but transited into physics. You know, you could come from maths or engineering to a surface science background. And in fact, I've had people from all those backgrounds in my group. And there are strong interfaces now, obviously, to life sciences in things like infection control. So I think it's a wonderfully interdisciplinary environment where you'll always meet lots of people with different knowledge and tackle some fantastic problems. So I'd really encourage people from whatever background that surface science can be a really fulfilling career for them.